Now moving on to our next graph, this one has a different function. That function is 1 over x squared plus 1. Again, they have us doing the same operation where we're going from -3 all the way to 0 as our domain, and we want to find out, well, what's the range on that? What is our minimum output to our maximum output? And again, we have a function where -3 has our minimum y output and 0 has our maximum y output. So what we can do is the same steps as before. We can put in our -3 into that equation. So we have 1 over -3. Again, I'll put it in parentheses, square that to make sure I get the entire -3x value squared, and then I'll add 1. Then what I'll get is I'll have 1 over 9 plus 1, which equals 1 over 10. And again, that's my lowest y value. So in my range column over here, for -3 to 0, I know that, again, -3 is my lowest value. When I put -3 in, I got 1 over 10. Close that off. And then to find out my maximum value, I'll put 0 into the equation. So 0 squared plus 1. That's going to be 1 over 1, which is going to be 1. So the range on this guy is 1/10 to 1 with x values with a domain of -3 to 0. So from -3 to 0, our values are 1/10 to 1. Again, from 0 to 3, we've got another situation like that going on. So we can go from 0 all the way to 3. And we can do the same process because, again, at 0, we've got our maximum y output. And at 3, we've got our lowest y output for that domain, just 0 to 3. So we'll do the same process again. 1 over 0 squared plus 1 equals 1 over 1, which equals 1. And 1 over 3 squared plus 1 equals 1 over 9 plus 1, which equals 1/10. The same way that we wrote it before, you'll notice, again, this time we go from 1 to 1/10. But when you're writing out the range, when you're properly notating it, you want to put the lowest y value or the lowest y output possible first, and then put your highest last. So that would be 1/10 to 1, the same domain as we had from -3 to 0.